In this video, we will evaluate the definite integral from 0 to 2 of the function x e to the 6x. Now, looking at the form of the integrand here, x times an exponential function, that leads us to using an integration by parts. Remember, a polynomial times an exponential function is well suited for this integration by parts. But keep in mind that this is a definite integral. So what we do is we take the formula for integration by parts, integral of u dv equals uv minus the integral of v du. And then we just throw in the limits of integration appropriately. So if we're integrating from a to b, that uv would need to be evaluated from a to b, and then definite integral from a to b. So let's go ahead and apply integration by parts. So we're going to let u be equal to x and dv be equal to e to the 6x. And whenever we have a polynomial times an exponential, this is a very good choice to make. U is the polynomial, dv is exponential. So v is going to be the antiderivative of e to the 6x, which will be 1/6 e to the 6x. And du is dx. So putting this together, integration by parts gives us uv, so that would be x over 6 e to the 6x, and then we subtract away the integral of v du. So 1/6 is going to be a constant that we can pull out front of the integral, and we're going to be left with the antiderivative of e to the 6x dx. Now this is a definite integral from 0 to 2, so we need to evaluate the first term from 0 to 2 and put in the limits of integration, 0 to 2. So for the first part, we plug in 2, we put a minus sign, we plug in 0. So when we plug in 2, we get 2/6, or 1/3, e to the 12th, and then minus away what we get when we plug in 0, which is 0. And then we evaluate that resulting integral. So the antiderivative of e to the 6x is once again 1/6 e to the 6x, and we're evaluating this from 0 to 2. So we have the 1/3 e to the 12th coming down. Then we have minus 1 over 36. And we need to plug in 2 for x, put a minus sign, plug in 0. So that would be e to the 12th minus e to the 0. And let's just simplify a touch here. We have 1/3 e to the 12th. And this minus 136 needs to distribute through and hit both terms. So we're going to have 1/3 e to the 12th minus 136 e to the 12th. So that will be 1136 e to the 12th. And then e to the 0, remember, is just the number 1. So we have minus 136 multiplied by minus 1. So this will be plus 1 over 36. So two key observations to keep in mind if you want to integrate a polynomial multiplied by an exponential. Integration by parts will typically work extremely well. And if it is a definite integral, what we need to do is apply that integration by parts formula like we normally would, and then we just add in those limits of integration appropriately.